In this problem, we are going to look at sequences. So the problem says that the algebraic form of a sequence is 1 over 3n plus 5. Let's write that down. So an is equal to 1 over 3n plus 5. It's asking which is the first integer term of this sequence. First integer term. So integers are 0, 1, 2, 3, 4, 5 and minus 1, minus 2, minus 3, minus 4, like that. So positive numbers, negative numbers and 0. And we know that n is the number of the term. So first term, second term, third term, like that. And we want to find which is the first integer term. So let's put n equal to 1. And we can see it will be 1 over 3 plus 5. And obviously it will come out as 5.33 because we have got a fraction. 1 over 3 is a fraction. So that's not an integer. We repeat for n equal to 2. And that's 2 over 3 plus 5. Again we have a fraction, so 5.67. Fraction means see 2, this 2 is not divisible. This 2 is not divisible by 3. So definitely we are going to get a decimal number. So that's also not possible. Next we'll put n equal to 3. So that becomes 1 over 3 times 3 plus 5. 3 and 3 can be cancelled. And then we will get 1 plus 5, that's equal to 6. Now 6 is an integer number. So that means we have got the first integer term of this sequence, which is 6. Then is asking write the integer terms for this sequence as another sequence. So we want to create a sequence with the integers, with the integer numbers, like means the terms which would be an integer. We want to find them out and write it as another sequence. So we'll write the algebraic expression which is given to us, and then already we know that n equal to 3 will give us 6. Now to get integers, we want to have n to be divisible by 3. Then only we will be able to cancel it out completely and get an integer number. So we'll think about the table of 3. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So we'll think about the multiples of 3. So let's check n equal to 6. We put 1 over 3 times 6 plus 5 and we get that as 2 plus 5, that's equal to 7. Then the next multiple in the table of 3 is 3, 6, 9. So 9. Then we put 9, solve it, and we get the number as 8. So our sequence is 6, 7, 8 and so on. Now the next question is write the sequence of the numbers leaving the remainder 3 on dividing by 5. That means we want to get the sequence of numbers when the remainder is 3 and we are dividing by 5. So remainder 3 means you should have plus 3. Yeah. And so I'm trying to get the algebraic form. So I'm doing part B first here. Part B is asking you to get the algebraic form. So we'll first get the algebraic form. It's saying the remainder should be 3. So that's plus 3. And we are dividing by 5. So it should be 5n plus 3, where n is the number of the term. So our general term becomes an equal 5n plus 3. So we did the second part, that is B part. We got the algebraic form of the sequence. Now we want to get the numbers in the sequence. So we can just put the numbers for n as 1. Then we'll put in the number of n as 2. So 5 into 2 plus 3. That is 10 plus 3, 13. Then repeat it and we get the first 3 terms of the sequence. Now you can cross check whether it is divisible by 5 and it is leaving a remainder of 3 when divided by 5. So if you take 8 and divide it by 5, you know that 5 times 1 is 5, and if you divide 8 by 5, then 3 is going to be left. Similarly 13, 5 times 2 is 10, but you can see that 10 plus 3, so we have got 3 as the remainder. Same for 18. So that means we have got the sequence of numbers which when we divide by 5 we'll get the remainder as 3.